Welcome everybody for our third video for sections 1.1 and 1.2. All right, so this is a very quick video here. We're going to be talking about just parameters versus statistics. So what is a parameter? A parameter is a numerical characteristic of the whole population that can be estimated by a statistic. All right, I haven't told you what statistic is yet, but we'll see. Parameter is a numerical characteristic of the whole population. So let's take a look at this example. So here I have a population of, I just made circles. All right, so you can imagine, I don't know what these are. I hope they aren't GPA of students, right? You can imagine maybe they were. All right, so here's our population, and you can see that I could put that in a list, the numbers in a list, and I faded it out because I'm imagining that this population just goes on and on and on and on. So the list just goes on and on and on, and we could measure a mean number from this population, and you might get a mean of 2.38 if you averaged all of the numbers in the population together. That population mean, that is the parameter. It's a numerical characteristic of the whole population. In this case, it happens to be the mean. Okay? So that's what a parameter is. Okay, what's a statistic? A statistic is a number represented by a number that represents a property of the sample. Okay? So here, look what I've done here. Out of the population, in light blue, I've taken a sample of these 5 circles. Okay? Based on that sample, I can compute a mean, an average, and I get 2.4. That is my statistic because it comes from the sample. So I'm doing the same thing. I'm making the same measurement that I made for the parameter, but I'm doing it on the sample. And that makes it a statistic. And if the sample is representative of the population, I would expect this statistic to approximate the parameter. And in fact, this is how we determine what parameters might be. Usually the population is too large, too vast, or it's too inconvenient to be able to actually make all the measurements that we would need to make. So we just can't compute the parameter. So what we want to do is we want to estimate what the parameter might be. So what do? We take a sample, just like this. And then we'd measure the statistic from the sample, and then surmise that perhaps the parameter is approximately equal to the statistic. You can see they're not equal, but they're close. Okay, so that's the difference between statistics and parameters. So here's an example. Let's identify the parameter and the statistic. So it says here, to determine the average, the mean, amount of money first-year college students spend at ABC College on school supplies that do not include books, we surveyed 100 first-year students at the college. We found that those students paid an average of $184. What is the statistic? Well, let's see what the sample was. We surveyed 100 first-year students. Okay, so the sample is the 100 first-year students. Right? That's the sample. And what did we measure from that sample? Well, we found that those students, we took the average, the mean amount that those students paid, and we came up with 184. So that's the statistic. The statistic is based on the sample. I know it's a statistic because it's an average based on the sample. Now, statistics don't always have to be averages, but it's a numerical measurement based on the sample. So what would the parameter be then? Well, what is this getting at? What is this approximating? Well, let's see. We surveyed 100 first-year students. So what's the population? The population would be all first-year students at the college. So the parameter would be the average paid by all first-year students at the college. Now, they don't tell us what that is. We probably will never know what it is, but that's the actual numerical amount. But that's what the parameter is. It's the average amount paid by all first-year students at the college, because that's the population. Let's go to some other examples here. Let's go to my browser, and let's look at some news articles. I'm actually going to start with this one. Okay, so many Americans are convinced crime is rising in the U.S. They are wrong, says this article. Okay, let's go down here. I don't want to read this whole thing, but let's find... okay. It says, take the crime rate. In 2019, according to a survey conducted by Gallup, about 64... Let me zoom in a little bit. 64% of Americans believe there was more crime in the U.S. than there was a year ago. Okay, let's just look at that statement right there. Okay. What is the statistic? Well, remember, the statistic's based on a sample, so maybe we can identify the sample. Okay, well, they surveyed some people. So it doesn't say exactly how many they surveyed, but we know that they surveyed some fixed amount of people. So the sample is the people that were surveyed by this Gallup polling company. All right? And based on that survey, they found that among those people surveyed, 64% believe there was more crime in the U.S. than there was a year ago. So this 64% came from a sample, and therefore it's a statistic. Now, what would the population the population parameter be? Well, the sample was collected from what population? Well, the population of all Americans, right? The sample came from all Americans. So the parameter would be the percentage of all Americans who believe there was more crime in the U.S. than there was a year ago. We don't know what that percentage is. That's why we took a sample. But that's what the parameter would be. The percentage of all Americans that believe there was more crime today than there was a year ago. Okay? Let's look at another one. Okay, here we have a sports article here. The Baltimore Ravens use their tight ends differently. Tight end is a position on the football team. Okay, so let's go down here, see if I can find the thing I was looking at. Oh, here it is. Okay, this statement here. Okay, out of 1,060 total offensive snaps in the regular season, Baltimore lined up 453 times, or 42.7% of its snaps, in heavy formations that featured different pairs of the tight ends plus Ricard. So they're just looking about how the football team lined up their players, okay? And they say that Baltimore, they 42.7% of the time they had heavy formations. Okay. Meanwhile, the rest of the league lined up for only 20% from heavy formations. Okay, I imagine that means they're heavier players. Okay, so the question is this 42.7%, is that a parameter or a statistic? Okay. Now, you might be tempted to say statistic here. But remember, a statistic comes from a sample. Where did this come from? Out of 1,060 total offensive snaps in the regular season, they measured every single offensive snap. The snap is when you hike the ball, right? I believe that's what they mean. So they measured, but the fact is that they measured every single one. All right? So that means that this measurement here, this 42.7, came from the population. Not just a sample, but from the whole population. So here we have an example of actually a parameter. Okay? A statistic would be obtained if you didn't use the entire population of 1,060 snaps. If you just used, maybe we'll just look at 30 of them and measure the percentage from those. Because you know what? I don't have the time or resources to get all 1,060, so I'll just lose 30. If I just used 30 and got a percentage, that would be a statistic. But because this came from all of them, it's a parameter. Let's look at one more. Some Republicans have gotten more concerned about COVID-19. All right, let's see. Where was this? Da-da-da-da-da. Oh, here it is. Okay. So, yeah, in early June, only 23% of Americans said there were not enough restrictions where they live. What are they talking? Restrictions. Let's read the first sentence. The YouGov HuffPost polls shows increased support for coronavirus-related restrictions. In early June, only 23% of Americans said there were not enough restrictions where they lived. But in the latest poll, that number has grown by 14 percentage points to 37%. Okay, so what is the statistic, or what are the statistics here, or what's the parameter? Well, let's see. Well, they got two numbers. They got 23%, they've got the 37%, and then they computed the difference between them. What were those based on? They're based on a poll. When you take a poll, do you measure everybody in the United States, every single American? No, you measure a sample of Americans. That's what a poll is. You take a sample. So that means that these are all statistics. We have the statistic based on June's measurement. We have the statistic based on the latest measurement. And then we have the statistic that is computed by taking the difference. So there's actually three different statistics here, okay, based on a sample of Americans. So what would the parameters be? Well, the parameters would be if you were to do the same thing, but for all Americans. Okay, so I hope that helped you identify the difference between statistics and parameters. And what we'll be doing in this class is statistics, finding the statistics, and then talking about how accurately they actually can be used to estimate our parameters. It's not just finding the statistic, but also giving a level of confidence to say, hey, I'm 95% sure that the actual parameter is this close, that I'm really close. You give a margin of error. So we'll be doing that later in the class. Anyway, I will see you next video.